Hello everybody, my name is Andreas Holzner from TNG Technology Consulting, and I'm going to talk about the journey of the last year where we participated in migrating RViz from ROS1 to ROS2. So just to make sure that we are all talking about the same thing, there's a picture of RViz. I think you all are quite familiar with it. The middle part is the 3D area where 3D scenery is shown and where ROS2 data is being visualized. Then you have some UI widgets left and right, and one big part of the RViz functionality are the so-called displays, which are pieces of code that subscribe to ROS2 data and then visualize it. So for example, for point cloud, you have a point cloud display which does the job of displaying point clouds in a proper fashion, and this can be configured inside of RViz. And one of the main goals was to just take RViz as it was and migrate it to ROS2 so that it can be used natively. Before we get more into the technical part, I want shortly talk about the people involved. On the one hand side, there were 4 people from TNG, my colleagues and myself. We are IT software consultant company, and we had no prior knowledge or experience with ROS, and we were hired from Bosch to help with the migration of RViz. Bosch from its side is using ROS2 for several development approaches, and they found it lacking in some points and said, okay, let's help out there, it's open source, let's contribute with migrating ROS2. One other use case for them is to use the ROS2 tooling on top of their own middleware. Because of the ROS2 middleware abstraction that's there, this can easily be done by them. And on the other hand, we had the upstream maintainer, William Woodall, who will also be talking after me, from Open Robotics, who had the pleasure of reviewing and merging all of our pull requests. And so let's just recap the goal. We had, of course, we wanted to migrate from ROS1 to ROS2. That's fairly obvious. The other thing I think most of you people are also familiar is that with ROS2, per default, all major operating systems are supported, Linux as in the past, and also Mac OS and Windows. And this was also part, and also the Windows use case is also a big point for Bosch. So this was also important to tackle the operating system issue. I won't talk too much about this because the libraries we use, Qt for the UI widgets and Ogre for the 3D stuff, they are already platform independent and work on all supported platforms. And there's still a lot of work to be done, but that's not very interesting from a ROS specific point of view, so I can't talk about this. There are some other things I can't touch because I have only 20 minutes, so if you're interested, feel free to come up and ask later. I'm around. So where did we start? We entered into the RViz endeavor last year summer, and when we looked at it, what was already done, William was already into the progress of starting the migration. The initial design discussions were mostly done. There was a minimal skeleton application present or prepared by William where we did start on. The old code base was roughly 40K lines of C++ code. It has roughly 5 to 8 years old. And there were a few tests, but not very much from a software development point of view. And also we had the issue of getting to know the code base first. Of course, one can start RViz and then take a look at what RViz is doing, but we had no deeper knowledge on what we expected for if we look at some piece of code, what it's supposed to do. So we needed to get this to know RViz code, and then we started with the migration. The steps we needed to do was first extend the initial skeleton to the full-blown application. RViz is now again, also for ROS2. Obtain and maintain the platform support, and then we needed to migrate the core functionality. We did this display by display once we had the basic stuff working. So we took every display, we made it compile in the ROS2 environment, and then we integrated it into the ROS2 version of RViz. There were Also for every new code and migrated code, we wrote unit and integration tests to have them covered. And we were thinking about, and we did actually introduce some kind of end-to-end tests. And why did it do this? When we looked at RViz 1, there were some tests present that consisted of some Python scripts, typically, that brought up some environment, maybe some publishers, and then you were supposed to manually start RViz, look at the screen, and consider whether it's working all right or not. And if you're familiar with the system, you can do that, but that's not automated. And ideally, you won't have to run these tests also automated, just to can be sure that your code, the code you wrote, is actually working fine. And on the other hand, if you're new to RViz and all the details, then it's really hard to judge whether the display or the application is working completely correctly. The basic things you can obviously see if it's crashing or not, if you see something like a point cloud on the screen, but that is have all the right attributes, and this stuff that's hard to judge if you don't know what you're looking for. So we also tried to improve the situation there. And this is the second thing I want to talk about. Then the first thing is what did actually change from the point of RViz when we switched to ROS 2 from ROS 1. And if we just look at what RViz is doing, then it's not that big of a deal actually, because if you think about RViz is just an application that displays ROS 2 data, so all RViz needs to do is to subscribe to some topic, and then for every message RViz is receiving, just display the data on the screen. And all the displaying stuff, that's then RViz internal, so that's almost no ROS 2 interaction. What's remaining is you need to somehow know of the coordinate frames. So the whole interaction of RViz with ROS is the node interface and a little bit TF. And it's turned out that from a semantic point of view, the differences are not that big. There are some minor syntactical changes, which are easy enough to deal with, and also with the support of William, that was easy to do for us. And then you have some difference, like the code, the types have different names, but that's also easy to adapt. Also, there's the ROS 2 migration guideline from Open Robotics. This is the first step you want to follow if you migrate some code. And based on that, there was not that much to do to account for the specific differences from ROS 1 and ROS 2. I mean, that's a fairly specific point for the RViz, as we just have this limited interface with ROS 2. Having said that, I want to continue with the end-to-end tests. And for that, let's first recap the how RViz, what RViz is doing at its core. And if you formulate it in a typically test sentence, then let's say you give them a point cloud message, for example. And then if I start RViz and if I activate the point cloud display, then I expect the point cloud to be shown on the screen, and according to the properties I switched on the display properties. So this is kind of one of the central RViz use cases. And what we wanted to do is we wanted to provide a way to automatically test these features of RViz. And of course, this does not replace unit or integration tests. And in integration tests, one can so far as to assert that if I have the proper test set up, maybe point cloud message, if I run the display code, then that the correct objects are getting inserted in a data structure that is then represented by Ogre on the screen. So this far I can go with normal integration tests, and this I can use to make sure I cover all the use cases and all the properties of a display. So I don't need to do exhaustive testing in an end-to-end manner, but I need to do like some kind of smoke tests so that I can make sure that the actual application is running, and an important part of that is the 3D rendering. If RViz works internally fine and the data representation is correct, but you see nothing on your 3D window, then it's not working. So an important point is that we need to include a 3D rendering in these kind of tests. And then we thought about it, and at the end, our conclusion was the only way to do this properly is to do your assertion with a screenshot of at least of the 3D area. Because that's the only way that you actually can make sure that you see all the correct data in the screen. And of course, these tests they run relatively slowly compared to unit and integration tests. So you don't want to do exhaustive tests in that manner, but combined with the unit and integration tests you can write some end-to-end smoke tests that guarantee you your RViz is working correctly. And we built something like that, and it took the name of the RViz Visual Testing Framework, which is a new sub-package of RViz, which is providing this functionality. And don't be afraid, this is going to be the only slide of code I'm showing. I just want to walk you through the test, because that's the actual example test. So what we do, we have some special test fixture which does all the heavy lifting, but then we start up a publisher, in this example a point cloud publisher, which is also publishes a very simple point cloud consisting of one single point. Then we set up the RViz window, so we define the camera perspective and make sure that the scene is pointing at the point we are publishing. We create a point cloud display, and we introduce the concept of page objects. So these of you that are familiar with web testing, they know the concept. You just define an abstraction for your web page, or in our case for the RViz application, so that we have an easy way to interact with RViz programmatically, and the tests are easy to write and read. So we say we set the topic of the point cloud display, we set the style, size, and so on. And then the last line is the assert, which basically says take a screenshot and compare it. And this is the example screenshot for this test I've shown you. It's just one single big point. And then we do a pixel by pixel comparison. And one wants these tests to be stable, work on all platforms, and so on, different window managers, and there are all kinds of difficulties when you run this on different systems. And for that, we want to have a high signal-to-noise ratio. And this we're getting by just focusing on a single aspect of the 3D scenery and scaling it up very high. So if we have, for example, and it may even be due to different graphic cards, some small differences like the sphere is being rendered at the corner, then the number of different pixels is very small compared to the whole number of pixels if the main features are big enough. And that's the way to get these tests stable. And before I talk anymore, let's see it in action. So this is actually a screencast of running the tests on a Windows. Behind in the terminal, I just started a callcon build or callcon test, and then in the visual test, RViz is started up. The display is currently being configured. Then we see the updated scenery. Whenever there's a slight pause, this is just to give some time for the screenshot to happen. We don't want to run into unstable tests due to timing issues. And then we play around with the display a little bit more, and we take new screenshot of the changed scenery. And after this is done, then RViz is shut down, and for the next test, RViz is started up again. The corresponding display is added by the test, it's configured, and then you can see here now, for now it's a small line, then we change the camera and the properties of the display to make the feature really big in the 3D scenery. And finally, when we have the picture set up, the properties, we take a screenshot, and that's it. And so what are the assertions we're using? This is a screenshot of the checked-in images in a repository, which are basically our test assertions. So just all images have in common that the actual feature is rather big compared to the whole image size, and that's again just to make sure the tests are stable. And it turned out that these tests, they were a really big help for ourselves. We got them merged and mastered, I think it was early this year. And compared, so we were with two ROS 2 releases during our time when we helped developing RViz. And it turned out for the second release, we had much less work to do because of the visual test, because we were absolutely sure that the things we migrated, they are working correctly. The combination of the integration test and the visual test gave us the security. They are working on all platforms. These tests are also being run on the Open Robotics Jenkins for ROS 2 jobs at least. They are not run on every ROS 2 build because it takes that long, but for RViz tests they are being run. And so this was a big help. The package itself, the ideas, they are independent of RViz. The page objects and this stuff is of course RViz dependent. But if you have also a graphical application, you might want to take a look at the code of this testing framework and maybe think about using something like that or similar ideas like yourself. So to almost finish up, I want to quickly talk about how far is RViz right now. And most of the features are there. On the README in the RViz repository, there's a big table of all the features and tools that are migrated. There's also a list of tables that is still missing. There's also documentation of how to write a plugin that documents the new plugin APIs of RViz. There's also documentation of how to migrate your display. So if you have a custom display and you want to have it working with the new RViz, just check out this documentation. There's everything there. It's the same recipe we follow if we migrated a display. And so it's, from my point of view, RViz is usable. Almost all displays are working. There are a few things that are not done yet. There are a couple of easy to migrate displays, like the temperature display. They're almost like very similar to the point cloud displays. There are a couple of them. There's a depth cloud that required image transport, and if you have seen on the previous talk, image transport is now on master, and it will be in the next release. So having that, it should be straightforward to migrate. The interact tool and interactive markers are missing. That's a little bit tricky because there is some server component associated with that. And there's the stereo display and Oculus display, which we haven't touched. But these are the only things we are aware of. Everything else missing. If you miss something, it's open source. So make a pull request and migrate it and chime in with your work. So finally, I want to thank all the people involved. These are my colleagues at TNG, Martin, who is also here, Andreas, Alessandro, Bosch for hiring us to do the work, and of course William, who is already standing to my right for doing the maintenance work of RViz and merging all our pull requests. Thank you. Are there any questions?
Yes, I have a question. When you're doing the test case selection or generation, do you use any tools to generate which types of tests, either manually or through like metamorphic testing, or some technique that randomly generates, like to explore larger spaces in the parameter space?
No, we don't. So when we migrate the display, the functionality is rather clear, and then we just think about what are the functionality features we want to have asserted for, and then we write the test. But we don't do anything like fuzzy testing or try to exploit on an automated way.
Thanks.
Thank you for interesting presentation. I have a question regarding a decision of this migration. Have you considered moving to the web-based tools, or it was in the scope of this task was only migrating this existing code base to the new platforms? And the second question, what is the ratio of the code which you added compared to the legacy code which was there?
So to the first question, we only entered the migration path after these decisions were done, and so we ourselves only read up the discourse discussions about whether one should change, and I think the agreement at the time was, and that's also where the Bosch motivation stems from, that RViz as a desktop tool is very valuable, and the goal was first now to migrate this desktop tool to ROS2. And I think there are also different visualization solutions, so if one wants to have something web-based, I believe the consensus is to just create your own tool to accommodate for that. And the second question, we only shortly looked into the GitHub statistics for this, so I'm not quite sure. I think we contributed around, it was to 16 to 20K lines of code which we changed or created. But if you want to know any details, I invite you to just check out GitHub. It's everything on. You can see everything on the ROS2 RViz repository, which is also on a link on the slide. So I don't have the numbers on my head at my head.
Thank you.
Only one more. We don't have much time. just yell. And in your experience, what do you find is a significant limitation of image-based testing?
It's difficult to get it stable because you really need to make sure that the signal-to-noise ratio is quite high. It's also the runtime of this test is very high because you need to wait for some time to be sure that the image on the screen is actually the one you expect. So if you just configure something on the application, then you immediately take a screenshot. You might just happen to be one frame too early or something like that, and to be sure that you don't get flaky tests for no reason, you need to wait. Apart from that, because of that, you don't want to test every single small feature this way, because the integration tests and unit tests are just a much quicker and easier way to get fast feedback. But that's the main point in my point of view why you don't want to do everything that way. If you have a test failure, to see why the test is failing, you need to look at both images manually. So we did not create tooling that shows us automatically the compared image, the image comparison in Jenkins. So it's easy to spot if you have a different image, and most of the time the difference was really big. So we didn't felt it was necessary to create tooling for that, but we don't have that.
Well, thank you very much.